Hi folks, Chris McClure here. We continue talking about the normal distribution, but this time we will be looking at the case where the distribution does not necessarily have a mean of 0 or a standard deviation of 1. But as we shall see, if we want to look up probabilities using the table, we would have to convert over to the standard normal distribution. Otherwise, I'll show you how to use your graphing calculator to calculate normal probabilities. Okay? So again, if you remember what we did yesterday or last time in looking up probabilities or calculate probabilities for the standard normal, this is just like it. But what we have to do is we have to take the value or observation x, if it's from a distribution that is normal but not standard normal, and convert it to a z-score. You just subtract the mean and divide by the standard deviation in order to get it to an equivalent z-score. Now in the statement of a problem, you're typically told what the population mean mu is and what the population standard deviation sigma is. So you take your observation x minus mu divided by sigma, round that to 2 decimal places. Now, when you take a non-standard normal distribution or any other distribution and you take all the values, all the observations in that distribution, and you take each value, subtract the mean, divide by the standard deviation, you end up with a new distribution that actually has the very same shape. Does not affect the shape. It just relocates the center to 0, and it gives you a standard deviation of 1. So when you take a non-standard normal distribution and you take each observation x and you subtract the mean divided by the standard deviation, you actually convert over to the standard normal distribution. Both of these distributions, the non-standard and the standard, have the same shape. It just has a different mean and a different standard deviation, but the shape is the same. You're just kind of rescaling it and recentering it. And as you look at the sequence of steps for finding areas under the curve, aka probabilities for non-standard normal distributions, these are exactly the same steps as for the standard normal that we talked about last time. The only difference is that you take your x value and you convert it to a z-score by subtracting the mean and dividing by the standard deviation. Otherwise, everything's the same. So we're going to take a look at an example here. Suppose that we take gentlemen from the Tall Clubs International. Actually, it's women, sorry about that. Women from Tall Clubs International, which has a requirement that women must be at least 70 inches tall. So all the women in this club must be at least 70 inches tall. But the women in general have a normally distributed set of heights with a mean of 63.8 inches and a standard deviation of 2.6 inches. Okay, so I'm going to say that's, again, women's heights in general, in the general population, women's heights have a normal distribution with a mean of 63.8 and a standard deviation of 2.6 inches. So what percentage of women satisfy this height requirement? In other words, if you were to randomly select a woman from the general population, what's the probability that she would be eligible to join the tall clubs? What's the probability that her height is at least 70 inches? We can calculate a normal probability. What's the probability that she'll have at least 70 inches? Now, here's a sketch of the normal distribution. with the mean of 63.8, standard deviation of 2.6 inches. And here we are at 70 inches on the horizontal. Now, if you were to take 70 inches minus 63.8 and divide by 2.6, you'd get 2.38. As in, a woman who's 70 inches tall is 2.38 standard deviations above the mean. I'm going to say that again. A woman who's 70 inches tall is 2.38 standard deviations above the mean. And then, if we look at the table, A-2, now let me pull up that table. I'm going to go back into my hard drive here. It's actually my shared drive. And I'm going to pull up that Z table that I showed you last time. Oh, there's my Z table. Pull up the Z table. Now that Z score is 2.38. Now, remember, when we look up the area under the curve to the left of that Z score, it's going to give us the area to the left. So if we want the area to the right, we subtract from 1. And here Z is equal to 2.3, and going out to here, we go out to the 0.08 column, which is the next to the last one. So 2.38 right here, the probability is 0.9913. Meaning 99.13% of the population of women have heights that are less than 70 inches. So if you subtract, this from 1 minus 0.9913, you'd get about, 0.087 or so. So less than 1% of the women have heights greater than 70 inches. In fact, it's 0.87% or so is the probability that a woman randomly selected would be able to join Tall Club. Okay, so I just showed you how to use the table. I'm going to stop right here for now on the slideshow, and I'm going to go over to my graphing calculator here. Here's my TI-84 calculator, and I'm going to go into the normal CDF by going into the distribution function, into the distribution distribution menu, go down to the normal CDF command. Now, you're going to put in 4 numbers here when dealing with non-standard normal distributions. The first number will be the left endpoint. Now, we want to go from 70 inches to positive infinity. Let's go back into our distribution menu. Sorry about that. Fumbled it. Normal CDF. Left endpoint 70 inches, comma. Right endpoint is positive infinity. And remember from last time that we wrote infinity as 1 times 10 to the 99th power, comma. And then the third number that you're going to put in here is the mean. In this case, what was the mean? Well, I forget, but let's look it up here. The mean was 63.8. So we'll type in 63.8 for the mean. And then, comma, the last number will be the standard deviation, which is 2.6. and then we'll hit enter after you do the close parentheses. And 0.0085484823 is what my calculator says. The area under the curve for this normal distribution not too different from this one right here. So again, don't get too worked up about small differences in these normal probability calculations. Okay, so I just showed you how to calculate normal probabilities when the mean is not 0 and the standard deviation is not 1. Remember that when you're using your graphing calculator, you're using the normal CDF, and you're just doing a normal probability calculation for a standard normal, all you need to do is input the left limit and the right limit. And when you don't leave it or put anything after it, you just put in the left endpoint and right endpoint, the calculator knows that you're doing it for a standard normal. But if it's not for a standard normal, then you have to put in the mean and standard deviation as the third and fourth numbers respectively. So I just showed you how to use the table and the graphing calculator to calculate normal probabilities. Now, if you want to work backwards using the table, then what we have to do is find the probability that is closest, as in the area under the curve to the left, that's closest to what we find on the table. Or in other words, look in the table. What table? It's this table right here. Look in the table for the probability that matches the area that's under the left, or at least get as close as you possibly can. And then look for the standard or deviation, aka z-score, that's closest. So if I want area under the curve to the left, that is 0.9913, then there it is, that's that probability, and we look to the left, 2.38 as the z-score, and then we can work backwards, for example. Well, don't worry, we'll do an example here. Okay. A z-score must be negative whenever it is located in the left half of the normal distribution. So if you know that you've got an observation that is less than the mean, that's going to correspond to z being negative, and vice versa. Areas are positive or zero values because of the fact that probability of any event is always between 0 and 1. With 0 being it's impossible, and 1 is that it's going to be certain. So how do we do the reverse lookup? AKA, what's the procedure for finding values for a normal distribution from known areas or known probabilities or known proportions, aka fractions? So you would sketch a normal distribution curve, enter the given probability or percentage in the appropriate region of the graph, identify the x values being sought, and then you use technology or table A2 to find the corresponding z value. And because of the fact that z is equal to x minus mu over sigma, then that means x is equal to mu plus z times sigma. Again, you will know what mu and you will know what sigma is from the statement of the problem. So once you find z, then you can take z times sigma and add that to u, and you'll have your corresponding x value. Okay, so let's do an example here. Same setup for women in the population. Mean of 69.5, standard deviation of 2.4 inches in this example here. What ceiling height, so what height for women, will allow 95% of men, excuse me, so this is for men, sorry, not women, but this is for men. So 95% of men to stand without bumping their heads. So what is the height corresponding to the 95th percentile, in other words? So we're going to use this 69.5 as the mean and 2.4 as the standard deviation. So focus on the 95%, or in other words, 0.95, area to the left. Area to the left because we want to find the height such that the proportion of men who have a height of less than this x value will be 95%. Or 95% of all men will have heights less than this height x that I'm looking for. So what is if we want to use the table, what is the z-score associated with 95% of the area to the left? So let's pull out our z-table. This is the second page, by the way. And let's find the probability in the main body of the z-table corresponding to 0.95. Now, it's going to be about halfway in between these two values. We have 0.9495 to the left, 0.9505 to the right. So if I want to find a z-score, I could locate that as 1.6, and then going up to the top, halfway between 0.04 and 0.05, so we can have 0.045. As in 1.645 is the z-score associated with the 95th percentile. So there's 1.645 for the z-score, and I have a standard deviation 2.4 and a mean of 69.5. So now all I need to do is take that z-score of 1.645, this little rectangle is supposed to stand for times 2.4, and then add the mean of 69.5. So 1.645 times 2.4, and then add 69.5. That works out to be 73.448 inches. As in, 95% of men will have heights less than 73.448 inches. Okay? That's how you do the reverse lookup. That's how you find an x value from a given probability, or a given area under the curve, or a given fraction of the population. That's how you work backwards. You find the z-score, multiply it by the standard deviation, and then add the mean. Now, I'm going to go to my graphing calculator here. Let's do the same problem. Here's my graphing calculator here. Go back into the distribution menu. Go down to inverse norm, which is option 3. Now we want to find the x value that's associated with 95% area to the left. So we're going to put in 0.95 as the first number, comma, and this is for a normal distribution with the mean of 69.5. So that'll be our second number, the mean of the distribution, comma. And then finally the third number is the standard deviation, which is 2.4. And we'll hit enter. And that gives us a height of 73.447448 inches. So about 73.5 inches then would be an appropriate height for the cabin of that plane. So that at least 95% of men can stand up without having to hunch over inside the aircraft. So what do you want to find? Do you want to find a probability from a known value of x, where x is the random variable for a normal distribution? Or do you want to find a value for x when you know a certain probability or area under the curve? Now, if you want to find the probability, then you can either use the table, as in the z table, or you can use technology. If you want to find the value of x from the known probability, then identify the cumulative area to the left of x, and if it's to the right, then subtract from 1 to get area to the left. Now, coming back over here for probability, if you're going to use a table, then take your x value minus the standard mean, from the population mean, and divide by the standard deviation. To take x minus mu over sigma, that'll give you your z-score. And then look up in your z table to find the area under the curve to the left, and then adjust as appropriate. If you needed to find a greater than sort of probability, not a less than, then subtract from 1. Otherwise, use your graphing calculator. You could also look these probabilities up using Excel and structure, and sure, in your textbook, and StatCrunch. Okay? And I showed you how to use the inverse norm to find your value of x. And I also showed you how to use your table to find a z-score associated with an area to the left. And once you find your z-score, you can multiply by the standard deviation and then add the mean to get your corresponding x value. All right, so look at the examples in your textbook, and then you've got some homework that I'm going to post here in a minute or two. Okay, so that's it for today. Tomorrow, I plan on hitting 2 sections, 6.4 and 6.5. And I see several of you have taken the exam, the midterm exam. If you haven't taken your midterm exam, please get into your testing center or proctor, take your test. Now, some of you still haven't contacted me. If you haven't contacted me to let me know where you're taking your exam, you need to do that like ASAP, because you're running out of time to take your midterm. All right, talk with you later, and have a good day.